Section: Introduction. In this section, we explore the capabilities of large language models, LLMs, in various areas, such as understanding language, answering questions, and performing creative tasks. With the advancements in LLMs, many believe we are entering a new era of artificial intelligence. The extent to which machines understand our world is crucial for their reliability in tasks like generating news, making policy suggestions, discovering knowledge, diagnosing diseases, and driving autonomously. The ability of LLMs to generate human-like text raises questions about their understanding of the world and whether they reason like humans. Causal reasoning is a key component of intelligence, as it involves identifying and understanding the cause and effect relationships between variables, rather than just recognizing correlations. This skill is vital in practical fields, such as drug development and public health planning, making it an important step toward achieving artificial general intelligence. We can formalize causal reasoning using causal Bayes nets, which help us understand the probabilities of certain variables based on others that are causally linked. By comparing human reasoning to these models, we can identify biases in human thought processes. Recent studies have examined ILM's reasoning abilities, raising concerns that they may rely on learned patterns instead of true causal relationships. For instance, introducing irrelevant information can significantly change LLM outputs, which questions their reliability in critical situations. Many researchers argue that LLMs struggle to generalize causal concepts beyond their training data without strong guidance. Therefore, it is essential to understand how LLMs reason causally and whether they exhibit similar biases to humans. To investigate this, we introduced the CLADDR dataset, which contains 10,000 causal reasoning questions aimed at assessing ILM's formal causal reasoning skills. While this dataset tests colliders, it does not compare LLMs directly with human reasoning. Additionally, the tasks require a solid understanding of probability and statistics, making direct comparisons with humans challenging. In our work, we compare human reasoning with that of LLMs by examining how both groups infer causal relationships. We focus on a collider graph where two independent causes affect a shared outcome. This setup allows us to explore different types of inferences, such as predictive and diagnostic inferences, and to identify specific reasoning patterns like explaining away. We analyze human data collected in previous experiments alongside responses from 4 LLMs: GPT 3.5, GPT 4o, Claude 3 Opus, and Gemini Pro. The LLMs were prompted with the same tasks as humans, using consistent temperature settings to ensure reliable outputs. We embedded the causal structure in 3 different knowledge domains to minimize the influence of prior knowledge on participants' inferences. Our goal is to determine whether LLMs reason similarly to humans and if their inferences reflect the domain knowledge present in their training data. We asked participants to provide likelihood judgments based on given observations, allowing us to compare human and LLM reasoning patterns. By creating this causal inference task dataset, we aim to facilitate direct comparisons between human judgments and LLM outputs, contributing to our understanding of biases in causal reasoning. Section Summary. In this section, we explore the capabilities of large language models, LLMs, in causal reasoning, comparing their inferences to human reasoning patterns using a newly created dataset focused on collider graphs. Our goal is to assess whether LLMs exhibit similar biases as humans and to understand the implications of their reasoning abilities for AI applications in high-stakes decision-making. Section: Results. In this section, we compare the performance of large language models, LLMs, with human reasoning. To start, we calculated the Spearman correlation between the inferences made by LLMs and those made by humans across different domains. The results show strong positive correlations, suggesting that LLMs demonstrate a level of human-like performance in causal reasoning tasks. Claude and GPT 4o had the highest average correlations, followed by GPT 3.5 and Gemini. This trend was consistent across all domains. We also analyzed the ILM's responses to various inference tasks. For predictive inferences, LLMs showed a clear increase in responses as the number of causes increased, similar to human responses. This indicates that LLMs understand that more causes make their effects more likely. However, when it came to the independence of causes, GPT 3.5 and Gemini incorrectly judged that the presence of one cause increased the likelihood of another, while Claude violated independence the least. In terms of effect-present diagnostic inference, GPT 4.0 showed the strongest tendency to explain away, followed by Claude and then humans. In contrast, GPT 3.5 and Gemini did not explain away, suggesting that they believed one cause would increase the probability of another. For effect-absent diagnostic inference, all agents rated the causes lower, with GPT 4.0 and Claude giving the lowest ratings, while Gemini aligned more closely with human ratings. We noted that LLMs tended to produce a wider range of responses compared to humans, possibly due to the experimental setup where LLMs generated single numeric values, while humans used an interactive slider. This difference in response style may have influenced the results. Next, we fitted a causal Bayes net, CBN, to evaluate the inferences made by LLMs and humans. The CBN parameters were treated as free variables and adjusted to minimize error. We found that LLM judgments correlated well with their fitted CBNs, with GPT 4.0 and Claude performing the best. Interestingly, LLMs benefited from allowing different strengths for causal relations, indicating they utilize domain knowledge more effectively than humans, who did not show this advantage. We also fitted a psychological model, the mutation sampler, to the LLM inferences. This model accounts for human causal reasoning and showed improved fits for most LLMs, except for GPT 4.0. These findings suggest that LLMs are influenced by similar factors as humans in their causal reasoning processes. Section Summary. In this section, we assess the performance of large language models, LLMs, in causal reasoning tasks by comparing their inferences to human judgments, finding substantial positive correlations, particularly with Claude and GPT 4.0. Our analysis revealed that while LLMs demonstrated sensitivity to causal relationships, they often treated these relations as deterministic, influenced by domain knowledge, and exhibited greater variability in their responses compared to humans. Section. Discussion. Sure. Please provide the text you would like me to paraphrase and simplify.